fluid coding, and AI, omp is making a very specific bet. The next coding agent upgrade may not be a smarter model, it may be a better harness. Hash-anchored edits, LSP refactors, debugger access, browser automation, subagents, and provider routing all live inside one terminal. First agent. The question is not whether another terminal chat tool exists. It does. The useful question is whether omp changes the failure modes that make coding agents annoying. Patches that do not apply, imports that break after a move, tests that loop without a debugger, and provider lock-in that forces every task through the same model. By the end, the practical answer should be clear. Test it now, watch it closely, or wait. omp, usually called omp, describes itself as a coding agent with the IDE wired in. That wording matters. The README does not position it as only a chat loop around shell commands. It lists file tools, search tools, AST editing, language server operations, debugger operations, browser automation, GitHub tools, task workers, and model routing. The product idea is that agent reliability depends on the control surface around the model, not just the model sitting in the middle. The most interesting evidence starts with editing. In a first-party benchmark, the author mutated files from the React codebase, gave models an English bug description, and compared whether the final file returned to the original after formatting. The headline was not that one model suddenly became magic. It was that changing the edit format changed success rates dramatically. Grok Code Fast 1 went from 6.7% to 68.3% in that setup when switching edit protocol. The mechanism is called Hashline. Instead of asking the model to reproduce exact old text, the file is presented with content hash anchors. The model edits against those anchors. If the file changed and the anchors no longer match, the write fails before the agent silently corrupts the wrong range. That does not make every edit correct, it changes a dangerous failure mode. A stale patch is supposed to fail closed instead of landing in the wrong place. The second big idea is that terminal first should not mean text only. omp says LSP is wired into write workflows, including file rename and move behavior through workspace will rename files. That is the kind of operation where a plain string edit can miss imports, re-exports, barrel files, aliases, and references. The agent still has to choose well. But if the language server already knows the symbol graph, the harness can ask the same system your IDE relies on. Debugger access is where the tool gets unusually ambitious. The README describes DAP support for LLDB, delve, and debug. That means breakpoints, stepping, threads, stack frames, variables, and expression evaluation can be part of the agent loop. For a segfaulting C binary, a hanging Go service, or a wedged Python worker, that is a different workflow from asking the model to add print statements and hope the next run explains itself. omp also brings browser automation into the same tool surface. The README describes a Puppeteer-based browser tool for headless Chromium or a browser attached through the Chrome DevTools protocol. It also says the same. API can drive Electron apps. That matters for web work because the agent can read docs, inspect a local app, click through a failing flow, and connect what it observes back to the code it is editing. The sub-agent story is not just run more agents. omp's task tool is described as using isolated work trees and returning typed, schema-validated results to the parent session. That is the important part. Parallel work is only useful if it does not create a merge conflict swamp or a giant blob of prose. The promise here is fan out with boundaries, review one area, diagnose a test failure in another, and return structured findings. Provider routing is the part that makes omp feel like a harness instead of a model wrapper. The model docs describe built-in models, custom providers, runtime discovery, provider overrides, canonical model equivalents, and local discovery for Llama, llama.cpp, and LM Studio. In practical terms, you can route different roles differently: a small model for cheap fanout, a slower model for planning, a local model for private work, and a commit role for messages and summaries. The tool list is wide. The README claims more than 40 providers, 32 built-in tools, 13 language server operations, and 27 debugger operations. It also describes packages for multi-provider model integration, agent runtime, the CLI and SDK, the terminal UI, and native bindings. Those are first-party claims, but they explain the design center. OMI is trying to make the terminal an agent cockpit, not just a prompt box with file access. As of June 1, 2026, the latest NPM distag and GitHub release in the research were version 15.7.3, published on May 31st. That release added and changed a lot: compaction primitives, eval-based sub-agent spawning, parallel and pipeline helpers for JavaScript and Python eval, token budget utilities, internal URL search, fuzzy picker filtering, and several streaming and terminal UI fixes. That pace is exciting for power users. It is also a signal that teams should test upgrades carefully. The benchmark evidence supports one strong, narrow claim: the harness can expose or hide modelability. In the current repository benchmark artifact from the research, Claude Haiku 4.5 reached 90% headline task success on the listed TypeScript edit benchmark, Kimi K 2.5 reached 85%, and Gemini 3 Flash Preview reached 80% through open router routes. But that does not prove OMI is the best coding agent. It says edit protocol and tool boundaries can matter as much as the model choice inside this tested suite. The trade-off is surface area, a tool that can write files, run shell commands, control a browser, touch GitHub, inspect images, use memory, spawn sub-agents, and attach debuggers is powerful. It also needs serious permissioning, local trust boundaries, and team policy. Bun is another dependency. Advanced provider routing means credentials compatibility, OAuth, local model discovery, and plan-specific behavior. Some powerful tools are setting gated, which is good for safety, but it means a demo and a real team setup may not feel identical. The practical verdict is this: OMI is worth testing if your bottleneck is not model intelligence, but agent mechanics. If patches fail, refactors miss imports, debugging loops waste time, or provider routing matters to your workflow, OMI is one of the more interesting open-source harnesses to evaluate. If you need a quiet, stable, low-surface area tool for a lockdown environment, wait, or test it in a narrow sandbox first. The thesis is strong: the coding agent is no longer just the model. The harness is becoming the product. If this helped you think more clearly about OMI, hash-anchored edits, and IDE-grade agent harnesses, like the video and subscribe to Fluid Coding and AI for more practical breakdowns of coding agents, AI tools, and developer workflows.